All right, folks, let's do a boat problem. So, before I begin this, I want you to remember that no matter what boat problem you encounter, it's always going to be some variation of what you see here. Okay, you may not be using the exact same units or calculating the exact same quantity, but you always are going to set up boat problems essentially the same way, which is to say that based on Archimedes' principle, you know that a boat floats, and so the mass of the boat, okay, or I should say the density of the boat, which is the mass over its volume, has got to be less than the density of whatever fluid it's floating in, and that's usually going to be water, okay, because we usually don't float boats in other than fresh or salt water. And again, usually the water that we are going to talk to you about is going to be fresh water, which is 1 gram per milliliter. So just remember that and don't get freaked out if you see a boat problem that's slightly different. Just think about what it is you're trying to find and solve it. So the boat problem I'm going to do is, if you're given a boat and you're given a mass and a volume so that you can get your boat's density, a very common question is, how much cargo can your boat carry and not sink? So let's do that. Here we go. Okay, so let's say the boat that I have here is 3,525 kilograms, 3,525 kilograms, and it has a volume of 5682 liters. Okay, so let's pause here for a moment and say, oh, kilograms and liters, is that a problem? Well, it shouldn't be. Let's talk about why that should not give you a problem. Let's go ahead and do purple. Why not? Remember that, let's assume that we're in fresh water, we're in a lake. And so that means that you're dealing with 1 gram per milliliter, per 1 milliliter. This is your density of water. But notice, if I multiply that by 1,000 over 1,000, it's just like multiplying it by 1 over 1. I haven't changed the value of it, but now it becomes 1,000 grams over 1,000 milliliters. And we have a new name for that. That's also 1 kilogram per 1 liter. Okay, so whether I'm giving you the density in kilograms per liter or grams per milliliter, okay, it's essentially the same kind of thing. So it doesn't matter. But remember, boats are large things. It makes more sense many times to use kilograms and liters. But the translation between the two is very simple. Just be sure that if you're in grams, that you're also in milliliters, and that if you're in kilograms, you're also in liters. Okay, so if you end up getting kilograms and milliliters, for example, you'd have to decide which one you're going to switch to make it equal to either, this one here. Okay, these are the ones that go together, grams and milliliters, or kilograms and liters. Okay, so just be sure that you have the right unit combination. Okay, so we have the density of our boat there, which is going to be its mass over its volume, and we know that 3,525 kilograms plus some amount of cargo over its volume has got to be less than the density of water. And what's our cargo? Well, let's say our cargo, and I'm just actually going to, let me erase this. Let's say what we're interested in, is saying how many, here's the question, question equals how many 60 kilogram people can the boat carry? Okay, now remember, you're going to see this same boat problem in a variety of forms. I could say, how many 1,500 gram sacks of gold coins could the boat carry? How many 500 kilogram cars could the boat get? It doesn't matter. It's the same idea. Basically, you're given the mass and the volume of a boat, and you have some kind of piece of cargo that you need to carry, and you need to figure out how much it can carry. So it's all pretty much done the same way. So let's go to the next slide and really set this guy up. Okay, next slide. So we know that the density of the boat, B-O-A-T, must be less than the density of the water, okay? Because if the density of the boat's greater, it's going to sink, right? So this is our basic idea. We have to know that the density of the boat is less than the density of the water. Okay, and so based on that, we say, density is mass over volume. Okay, well, we know what the density of water is. The density of water, for our purposes here, since we're in a freshwater lake, is 1 gram per milliliter, which is equal to 1 kilogram per liter. Okay, so this is based on the units we're using. The 1 kilogram per liter is the density we're using for water. Okay, so we need to set our boat density to be less than the density of the water. Okay, so let's look at our numbers. That means that the mass of our boat, which is going to be 3,525 kilogram plus 60 kilograms, that's how much a person weighs, times x. X is whatever number of people we can carry. We don't know. That's what we're trying to find out. And what's the volume of our boat? 5682 liters has got to be less than 1 kilogram per 1 liter. Okay, so these all have to, this is our problem, and we are looking for x. X is what we're trying to find. Okay, to make this equation, this basic algebra equation, true. Okay, so let's start off on the next slide. Okay, so 3,525 kilograms plus 60 kilograms times x over 5,682 liters is less than 1 kilogram per liter. I think you can see that the first thing we're going to do is multiply both sides by 5,682 liters. Okay, now if you multiply the left side by 5,682 liters, I hope you'll see that it will go away. Okay, and if I multiply it on this side, 5,682 liters, notice the liters cancel out. Okay, so let's write our new expression. 3,525 kilograms plus 60 kilograms times x is less than 5,682 kilograms, because liters canceled out. So we've gotten rid of the liters. All we're left with is kilograms. That's great. So all we're doing now is working in kilograms, and that's perfect, so we don't have to worry about canceling out any other units. Now I think it probably wouldn't be too hard for you to see that the next thing we need to do is subtract 3,525 kilograms. So minus 3,525 kilograms. Remember, our whole goal is to get x by itself. Minus 3,525 kilograms. All right, so we're now going to write our new expression, okay, which is going to be 60 kilograms times x is less than 5,682 minus 3,525, which is 2157. 2157 kilograms. Ooh, we're getting close now. Finally, I think you can see that all we need to do now is divide both sides by 60 kilograms in order to get x by itself. Okay, that's of course going to get rid of the 60 kilograms on that side. Interestingly enough, the kilograms are also going to go away on that side, and we're going to be left with no units, which is fine because we're just looking for a number of people, right? So the real problem is going to be x is less than 2157 divided by 60. Okay, so next, so x is less than 2157 kilograms divided by 60 kilograms. X is less than 35.95. Now, here's the deal. X has to be less than 35.95. And remember, you can't have a decimal when you're dealing with like a whole item. So like a person, you can't have 0.95 of a person. That doesn't make any sense. So because X has to be less than that, we will say that in the final answer, if I will round down and say X then is equal to 35 people. Okay, remember this takes a little bit of thinking. If you have a bag of coins, I guess you could take out some of the coins, but the point is you're supposed to, if the question is how many of these items can you take, it's not asking you how many of them plus a percentage of them can you take. It's like how many whole items can you take. So you have to remember and give your answer usually in a whole number, okay? And usually you're going to be rounding down because if X is 35 people, you know that you're not going to exceed the density of water and your boat will float. Remember, if X were 36 people, that would be too much weight. Your density would be greater than the water and your boat would sink. Okay, well, I hope that was helpful. All right, and this is a great example for your boat problems and should get you through most of them. Talk to you soon. Bye-bye.